All right, so before we begin this video, I just want to make sure that you have completed all the questions prior to this one. All right, this one is definitely more of a challenge, and if you haven't completed and mastered the first 6 or 7 questions on the worksheet A through F, okay, do that before you move on with this question. Okay, so question G, mosquitoes and other biting insects can cause a great deal of discomfort. They can also spread diseases that threaten public health in many areas of the world. The seed oil of a plant, commonly called the physic nut, is burned in lamps in India and parts of Africa to repel biting insects, especially mosquitoes. A scientific investigation was done to identify which chemicals in the oil were responsible for deterring mosquitoes. 3 chemicals in the oil, specifically palmitic, linoleic, and stearic acids, were tested to determine their effectiveness against mosquitoes that spread 2 deadly diseases in Africa: yellow fever and dengue fever. In the study, okay, palmitic acid was determined to be the most effective chemical. So palmitic acid was determined to be the most effective chemical, providing 3 times the protection of stearic acid. And again, palmitic acid was 10 percentage points higher than linoleic acid. Okay. Um, the effectiveness percentages of stearic acid plus linoleic acid together, so stearic acid plus linoleic acid together, were 5 percentage points higher than palmitic acid. All right, so a lot to break down there. Let's take this step by step. The first step of these problems is to determine what the question is actually asking us. So we are trying to determine the effectiveness of stearic acid in repelling mosquitoes. Okay, so in that first sentence of the second paragraph, it says palmitic acid was the most effective, providing 3 times the number or 3 times the protection of stearic acid. Okay, so palmitic acid is being compared to stearic acid. Okay, so if it's getting compared to stearic acid should be our starting point. So I'm going to say that S is equal to the effectiveness of stearic acid. Okay, and we don't know what S is. That's our starting point. So we're going to call that X. Okay, and so if S is equal to X, okay, stearic acid is equal to X, then palmitic acid is 3 times that, okay? So hopefully by now we've kind of gotten the hang of this, all right? 3 times multiplication, okay? So it's going to be 3 times X. So the other unknown in this problem is the effectiveness of linoleic acid. Okay, so I'm going to call linoleic acid L, all right? But there's a few more steps you need to take to actually figure out what that is equal to, what expression L is going to be equal to. Okay, so I'm going to go in a different color and do some work over to the side here. Okay, it says that palmitic acid was 10 percentage points higher than linoleic. All right, well, that doesn't seem too complicated, okay? So palmitic acid is equal to linoleic acid plus 10. All right, but I want an equation for L, okay? Right now this is solved for P. So I need to figure out a way to rewrite this equation here as L equals something, all right? So if P is equal to L plus 10, okay, if linoleic acid is 10 percentage points more effective, okay, we could also say that L is equal to the palmitic acid minus 10 percentage points. So we could say that L is equal to P minus 10. All right. So again, palmitic acid is equal to linoleic acid plus 10%. All right. So if we just kind of reverse that, linoleic acid is equal to palmitic acid minus 10%, right? Palmitic acid is 10 percentage points higher. Okay, in other words, linoleic acid is 10 percentage points lower. All right, but again, I am trying to just plug in a number for S and then help me find P and L. But if I know what S is, I can't just plug S into this equation. I don't have an S in here. Okay, so I need to rewrite L with S instead of P. Okay, so P is equal to 3 times X. Okay, and again, the percentage points of stearic acid is X, palmitic acid is 3 times X. So if P equals 3X, I can just take this 3X and replace that P with it. So instead of L equals P minus 10, I can say L equals 3X minus 10. Okay, so L is equal to 3X minus 10. All right, and the next part that's kind of tricky about this problem is to figure out what exactly goes in the do column and what exactly goes in the decide column. So we are given that stearic acid plus linoleic acid is 5 percentage points higher than palmitic acid. Okay, so if we have stearic acid plus linoleic acid, that should be equal to palmitic acid plus 5. Okay, so now let's go through and plug in a value, percentage points for stearic acid. Okay, and once we do that, we have equations here and here that can give us the percentage points of palmitic and linoleic. Okay, so linoleic, palmitic. So I'm just going to throw out a guess. All right, let's just say that stearic acid has a 10% effectiveness against these diseases. Okay, so if stearic acid has a 10% effectiveness, then linoleic acid is 3 times that 10 minus 10. So we go 3 times 10 is 30. Okay, 3 times 10 is 30, and then 30 minus 10 is 20. All right, and then palmitic acid is just 3 times stearic acid. So 3 times 10 is 30. So now I move on to the do column. Okay, so in the do column, we are adding stearic and linoleic acid together. Okay, so in this case, in this trial, it's 10 plus 20, and we want to determine, is that equal to palmitic acid, which in this trial is 30 plus 5. Okay, so 10 plus 20 is 30. All right, and 30 plus 5 is 35. Okay, so we see that when we add stearic and linoleic acid together, we are too small. Okay, we are less than palmitic acid plus 5. Okay, so if we're less than palmitic acid plus 5, our answer is too small, and we need to try a bigger number for stearic acid.